Yes, yes. Damn, son, where'd you get that? Damn, son. Let's see. Right here, sound quality. Check, 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 check. That's not bad. I feel like my mic could absolutely be closer to me. And pointing directly at me. That's beautiful. Most of the time, I guess I am kind of looking this way. Maybe that's better. Maybe it should look like that. Excuse me. Let's see. Is my volume all the way up? Now it is. Okay. I think that's actually. I think that's fine. Excuse me. That's acceptable. Oh shit. I had my desktop audio on. Now you guys heard the feedback. Oh well, I don't think anybody's tuned in yet, so that's fine. Okay, that's cool. That's cool. It's cool. It's cool. It's cool. Let's get rid of that. Where's my second window? We're gonna be doing some homework. Let's see. I want to see my stream on here. See that it's good. Kick.com, baby. Kick.com. What's happening, shit? You heard? Cool. What's happening, shit? What's happening, shit? Whoa, whoa. What's with the spam? None of it showed up though, right? What's with the spam? None of it showed up though, right? Okay, there's one showed up. Bro, get your bot ass out of here. It's always that Nesna.com bullshit too. Okay, I don't want to hear the feedback anymore. Bro, get your bot ass out of here. I don't know how none of these showed up too. This must have been because that was from earlier stream. Or a different stream. Whatever. It's kind of cool to see it pop up on the chat though. Like regardless, to see it pop up on the screen. So I fuck with it. Do whatever you want. Post whatever you want in the chat. Okay, free reign here. I don't have any moderators. Say what. Maybe I shouldn't suggest this. I was going to do my homework in pen, right? We're working on differential equations. But I don't think that's a good idea because I actually can't erase or anything like that. I don't have no whiteout. So I was going to do it with pen for the purpose of it was a much better display. It comes out darker, of course, right? As opposed to graphite. But we're just going to continue with the pencil so I can erase because I am undoubtedly going to make mistakes. Alright, so this is our problem that we have. We have a third order differential equation. Alright, so let's get started on it. Let's see. Oh, yeah, that's the one thing I wanted to check. Here, we'll write it out first. How hard is that to see? It's a little difficult to see, not going to lie. Let's see if we can alter these properties here so that exposure. That's what I want to turn the exposure down 1. Shit. Not really doing it. It's still pretty hard to see. I don't like that either. Now it's too dark. What happened to the configure video? Just cancel. But yet it stayed. So it doesn't really make any sense. Configure video. It still popped up somewhere. There it is. Jeez. Okay. Okay. I'm a numbers guy. Okay. This shit ain't working out too well. Exposure. Let's go back to where it was. I'm gonna lock that, put that on auto. Let's go to the brightness. Maybe it's a little bright. Turn the... Oh, that's doing it. That's definitely doing it. Okay, let's apply that. Contrast. Could... What? Turn the contrast up? How much is that really affecting it? I'll just leave it right there. I don't want to do sharpness. Turn the sharpness up. So we can really define those numbers and shit. Okay. Okay. Okay, let's get rid of this. I don't know what's going on. Okay. Alright, I think perhaps that looks good. Let me see, Well, that doesn't really do anything for me. Let me go to my stream. That's what, on my phone. Let me see on my stream on my phone. Yo, I just gotta make sure the quality is superb. Okay, so bear with me. Alright. Definitely not in 1080 right now. Oh, this motherfucker. Advanced. Give me 1080p, bitch. Okay. That's not bad. It's just we're so zoomed out. I don't want to zoom in either. That's not bad at all. It's not bad at all, but I don't want to zoom in either because it's going to be a long problem. There's definitely going to be many calculations involved. That's why, let's see if we wrote with pen. Well, if the pen was good, how much better it would come out. And I can write bigger. See, that's much better. That's much better. Oh man, just the whole erasing aspect though is kind of a big deal. What if I don't even know what this is. Is this a pen? Ooh. That's like really nice, right? I think I'm gonna roll with this. Let's see how it goes. And then if I really start messing up a lot, then we'll figure it out. We'll figure it out indeed. Alright. So we have a third order differential equation, third order linear differential non-homogeneous, third order linear non-homogeneous differential equation. Right? I think I said all of those words in the correct order. Anyways, let me go ahead and record this because this seems... Alright, we got a third order non-homogeneous linear differential equation. Okay, so we're going to use variation of parameters to solve this. Let's go ahead and get right into it. As you can see, I have my problem here. We're laying it out. 27y. Whoops. 27y. That's the derivative plus 27y. 27y. Okay, equals e to the negative 3x, e to the negative 3x. Boom. Just like that. That's a 3. That's a 3. Okay, using variation of parameters. First thing we must do is solve for our roots so that we can find our solution to the homogeneous equation, and we can use these distinct solutions to solve for our particular solution through the method of variation of parameters. Okay, so first start by solving for the roots. Alright, and what we're going to do is we're going to convert this to a characteristic equation by just essentially just substituting an r, and of course we have our respective orders as exponents. I didn't need to put that one there, but whatever. 27. Okay, equals 0. That's our characteristic equation. Now, we can imagine we're just going to essentially... just start subbing in some numbers. We're going to take some guesses and we're going to see if it works out, because it's kind of all you can really do when you have a polynomial to the third power, or to the third order, a polynomial to the third order. So we're going to assume, let's try 2. 2 to the power of 3 is 8. 2 squared is 4 times 9 is 36. 8 plus 36, that's going to be all positive. So it's definitely going to be a negative number. Okay, it's definitely going to be a negative number. So, negative 2. 2 times 27, negative 40, negative 50, 40, wait, what did I just say? 2 times 7, 14, negative 40, 58, 54, fuck. Negative 54, 2, negative 8, negative 54, negative 8, negative 62, negative 62, 9 times 4 is 36, 27, we had negative 62, 36, 27, 56, 7, 30, wait, really? Or did I do that wrong? Oh, okay, let me take a sip of the Red Bull. I don't think I'm quite there yet. Okay, I'm the definition of a numbers guy. Okay. Alright. Let's try it again. Negative 2. Okay, negative 2 cubed is negative 8. We'll go ahead and negative 8 plus, that's going to be squared. We're going to write it out. Negative 827 times negative 2 is going to be 47. That's 40. That's 54. Negative 54. This is going to be 9 times 4 is 36. Negative 2 squared is 4. Positive 4 times 9 is going to be 36. Plus 36. And then we have just plus 27. Okay, and then we have negative 54 minus 8 is going to be 4. 8, that's 12. Negative 62. Yeah. Plus 36, 27. That's going to be 56. 56. It's going to be 63. Really? 63? Yeah, I'm 63. Oh, we're just about there. Just about there, but not quite. Just not going to happen. Well, I'm just expressing my math right now. Simply 1 off by a substitution into a third order polynomial, because we're trying to solve for a third order differential equation through variation of parameters. That's all true. That's all very true. Alright, well that didn't fucking work. Alright, I guess let's try 3. So 3 to the third power is 27. Okay, negative. Negative 27 plus 3 squared and 9, 81. 81 plus 27 times 3 is going to be 60. 7 times 3, 21. 60, 81. Negative 81. That's my bad. Wait, so that's it. Okay, plus 27. Boom. That is accurate. That equals 0. Therefore, our first solution to one of our roots is r equals, what do we just plug in? Negative 3. R equals negative 3. Okay, now, through synthetic division, we're going to divide this polynomial by the root negative 3, okay? So, in order to do that, we'll set it up like this. This is just the classic setup for the synthetic division. We'll go ahead and put our divisor right here, and our dividend, which is the polynomial right here. Well, the coefficients of the polynomial right here. We'll understand that each coefficient is like I forgot the word I was gonna use. Oh well. So 1 for r cubed. Our coefficient's 1. Positive 9. Positive 27. Positive 27. Okay. This one comes down for synthetic division. Now we take the divisor. We take the divisor multiplied by the leading coefficient. Okay. So in this scenario, we pull down the 1. That's just normal standard operation. Pull down the 1. Now we're gonna multiply negative 3 by 1. Now we have negative 3, and we're gonna add this to the following coefficient. Okay. The following coefficient. So 9 minus 3 is going to be 6. We have 6 times negative 3 is negative 18. 27 minus 18 is it's 9. Positive 9. 9 times negative 3 is negative 27. And that's 0. Perfect. If you don't have a 0 here, you therefore have a remainder. And you shouldn't have a remainder. If you do, I haven't done much of it. I don't know what happens at that point, but you shouldn't have a remainder in any of these problems that we do for a synthetic division of a third order polynomial. Okay, so now we've derived our next polynomial, which will be a second order polynomial. Okay, so now this is going to look like r squared plus 6r plus 9 equals 0. So now we can go ahead and solve by this through factoring. So we know that r plus 3 squared equals this polynomial here. So now we have a root of multiplicity. Woo, we got a root of multiplicity 3. Okay, because again, r equals negative 3 even for this, so we have a multiplicity of 3. Therefore, our solution to the homogeneous equation would look like this. Would look like y. We'll just put h for homogeneous equals. Well. Never mind. I don't know. There's no reason to write this out. So let's just scratch that. We're just going to say our solutions are e to the power of -3. What are we working in? We're working in x is our variable. Oh, holy shit. And it's, oh no. And it's our root, or it's a or what's the correct terminology to use? Anyways, the root shows up here too. It shows up here too, which causes additional changes. Okay. How would that affect this, though? Let me think. How would that affect this? Cool. Okay, I'm a numbers guy. Okay, I'm a numbers guy. Man, I can't get that shit out of my head. Okay. So we have a multiplicity. Okay, so I assume y2 equals x times e to the -3x. y3 equals x squared times e to the -3x. So those are our solutions. I'm trying to think where this plays a role also. Would we just go ahead and start if it shows up in the root? Oh man, I think we're gonna have to ask AI. Because I know when we use non-defined coefficients, then we're gonna go ahead and do a different manipulation, considering that our root is in the exponent. But for variation of parameters, I'm trying to recall if that's necessary. For variation of parameters, okay, let's hop over and ask AI a question. I'm trying to think about how to word it properly, also, but I'm not really certain. But we'll figure that out. Okay, we're just gonna go here to AI. Hey. I just want to get off of my home screen, so I'm going to say some stupid shit real quick. And then we'll switch over here. I'll show you what I'm working on right here. Okay. What's the first thing you'd like to know? Okay. I have a third order non-homogeneous linear... I think it's linear, isn't it? I'll just say third order non-homogeneous differential equation. I have a third order non-homogeneous differential equation. The root is -3 with a multiplicity of 3. If multiplicity of 3 and the equation equals e to the power of -3x, considering my root is in the exponent of the function which my differential equation equals, is there any additional variables I must... Okay, so equation considering my root is in the exponent of the function which my differential equation equals, I have and considering my root is in the and my my solutions to the homogeneous equation is e to the power of negative 3x, or here, I'll write it like y1 equals e to the power of negative 3x, y2 equals e to the power of x times e to the power of negative 3x, and y3 equals x squared times x squared e to the power of negative 3x. Is there any additional manipulation required, such as multiplying each solution by another x because of the root being in the exponent of the right side of my differential, my non-homogeneous differential equation. Alright, let's see what he says. Let's give it up to him. See what he says. Whew. We're required to find the particular solution for your non-homogeneous differential. Since your form is already contained within your homogeneous solution set, you must multiply your trial solution by xk. This is the multiplicity of the root. R equals negative 3 when this gives you the complementary solution, determining the trial particular solution. Homogeneous term is under the method of undetermined coefficients, your standard guess. Undetermined coefficients. That's not what I said earlier. I said like undefined, undetermined. Your standard guess would be yp equals blah blah. However, because all parts of the homogeneous solution, this guess is redundant. To ensure the particular solution is linearly independent, you must multiply x repeatedly until it no longer overlaps with yc. So, the final form. Well, I am using variation of parameters. Considering this is an extra manipulation required. No, additional manipulation is not required when using variation of parameters. Okay. Alright, baby girl. Cool. Alright, so let's get back to it then. So we're not going to do any additional manipulation. We're just gonna go ahead and we're gonna move on forward there, bud. We're gonna move on forward there, bud. Move on forward there, bud. I wanna add some oh yeah, that's the other thing I was gonna check. I want to check if my last live got copyright. Oh, fuck. I can't really determine if that's accurate or not. It did. I'm honestly so sick of that happening, so I'm just not even going to play any music. Honestly, it annoys the shit out of me, so I'm just not going to play music. Man, I gotta do some more shorts. But alright, let's go ahead and do this. So we're not gonna do any further manipulation. We're gonna go ahead and use this in our matrix. So we have a 3x3 matrix. It's gonna look like this: e negative 3x, x e negative 3x, x squared e to the negative 3x. Yikes, that's gonna be a lot though. That's gonna be a lot of calculations. Text me. Hold on. Okay, sure, bud. Spam. That's absolutely spam. All right, now to complete this matrix, we have to derive these. We have to find the first and second derivative of each of these functions, which we're going to have to use integration by parts, and it's going to be a lot. I mean, not a ton, but I mean, it's gonna be a little bit. All right, so let's do that. Man, solving for this determinant's gonna be fun. It's gonna be so fun. I can't even fit it there. That sucks. Alright, we'll come down here then. Whatever. Okay, so again, this is first derivative of this function, second derivative of this function again, first derivative this function, second derivative of that function, first derivative of this function, second derivative of this function. Okay, so now we have our 3x3 matrix. We're gonna go ahead and solve for the determinant of a 3x3 matrix, and this is gonna give our fundamental Wronskian, our initial Wronskian, whatever you want to consider it, and then from there we're going to use a method to solve for our individual Wronskians, which will allow us to solve for our independent variables. Will allow us to solve for our solutions here, y1, y2, and y3. Yeah. Yep. All right. So go ahead and solving for the determinant of a 3x3 matrix. Yeah, no, this is correct. Yeah, granted, I could have simplified that. Totally should have, so it would have been less messy, but whatever. I'll do it on the next step. So you have a negative 3 and a positive 9, so 6x e to the negative 3x minus 3e to the negative 3x. Great. Like that. Bracket that off. Okay, so now that's our first, that's one of three. That's one of three dimensions in the 3x3 matrix. So let's solve for the second dimension, which begins with a negative. So negative xe, negative 3x multiplied by These here. I did that right. Yeah, I did that right. -6 minus 12. Messed that up pretty bad. It's meant to be ease. Shit, did I do that here too? Fuck. Well, no, because I didn't use that yet. Man, I'm so retarded. Okay, let me do that. And again, this is also meant to be an E. Yikes. Okay. Okay. Now it just got really messy. And I'm losing track of where I am. Alright, I think we're good though. Okay, now this is going to be an addition to our third dimension of the 3x3 matrix. Where are we at? We're right here, so... No. The fuck? Oh, it's so annoying. Okay. I really have to do all this? Like, do I really have to do all this? Holy shit, man. I really don't want to do all that. I can't believe, for real? Pisses me off. let's see if there's a shortcut to solving this matrix. Because to distribute all of these variables, I'm just gonna get so many fucking variables, and like, bro, I don't want to do all that. It's such a waste of time. And my fucking mouse keeps lagging. Oh man. Cortisol is rising. Y1, Y2, and Y3 to start. Would you like me to set up the Wronski matrix? Yes, please. Y1 equals e to the power of negative 3x. Y2 equals e to the power x e to the power. Let's see if AI can give us a shortcut, because I'm already falling asleep thinking about all this bullshit. How did I get an X right here? What? Oh, okay. What the? Yeah, I'm obviously just. You can simplify the calculations by factoring out e to the negative 3 from each column or each row. This leaves you with row operations, adding 3 by row 1 to row 2 and subtracting 9. The determinant simplifies significantly. Row operations, adding 3 by row 1 to row 2. That's what I want to figure out, is the row operations. Dude, I'm so fucking hot right now. Why is it so hot? Holy fuck. Okay. Alright. I'm chilling. Oh, super. I don't know. I got a Red Bull, but it seems to just make me more fucking tired. So maybe I should just go like fall asleep or something. I don't know. I wonder if I laid down if I could fall asleep. I just started the stream though. Maybe it's the math is making me tired. Maybe the math's putting me to sleep.